Hey everybody, happy Friday. Hope you guys understood yesterday's work. First thing I'm going to do today is I printed out to run off a key for you guys. So at some points you could do it after this lecture. You probably want to do this after the lecture actually. But I made a key for the work from yesterday. Maybe somebody can hand it out or Mr. Robinson can find it and give it to somebody to hand out. So you can check your work from yesterday. See if you got the right answers. I know some of you may be confused about how to convert from radians to degrees or how to find a coterminal angle. So I'll give you guys the paper so you guys can see if you're on the right track, or if you can look at the answers, maybe that'll help you out and see if you understand it. Today I'm actually going to jump ahead to section 4.5 in your notes. So maybe you could take a quick moment, so if you need to pause me or whatever, but I want to do section 4.2 first. Obviously I want to go in order, but I don't think it's as easy to explain over a video. So we'll do section 4.5. And then if we have some free time, I was thinking maybe I could show you guys some pictures of the baby. Some people have been asking if they could see the baby, so I'll show you some pictures at the end of the lecture. So section 4.5, it's everyone's favorite topic. It's how to graph. So how do you graph sine and cosine? Some of you may not even know what sine and cosine are. Sine and cosine are functions that relate to a triangle. So based on a relationship inside a triangle, there are two key terms that I believe you guys learned for sure in geometry, but they're called sine and cosine. And how do you graph it? Okay. And again, all this stuff we're going to do into radians. Those of you that are going into calculus or going into some sort of medical or scientific major, like we did at the beginning of this class. Remember how we did those PowerPoint presentations? You need to have a strong foundation in sine and cosine, or a strong foundation in trigonometry, and that's why we're going to spend one whole quarter doing this stuff. Okay? So how do you graph it? Okay. So what we're going to do, first of all, here's our objectives. You should know how to draw it, how to use amplitude and period, and then do some translations. Okay. This right here, this picture right here, is the picture of the sine graph. So remember how you always had in any graph that we always had some sort of base or foundational picture, and we always like shifted it and move it up, down, left, right. So if I gave you like x squared, it was always a parabola, and then depending on what numbers there, you'd move it to the side or up and down. Same thing with log, or same thing with 1 over x. We kept on taking a graph and moving it, and sine and cosine are no different. The first thing you need to know and practice is, how does the basic graphs for sine and cosine look like? Well, they actually look like waves, and of anything, sine and cosine are probably the most real life application that you'll do in math. Every time you plug something in, or when you do something with electricity, it actually goes in a sine or a cosine function. It's actually a wave in which electricity is generated. So most things, or even light, they all travel in waves. So they use some sort of base model of sine and cosine. Sine is very simple. It starts at 0, 0. And you make a wave. You go up and then down and up and down, and it repeats forever. But we only care about the first, what they call the period, like the repeating part. So all I care about is from 0 to 2 pi. So I go up at pi over 2, I go down to 0 at pi, I go down to -1 at 3 pi over 2, and back up to 0 at 2 pi. And then that exact same piece gets repeated over and over and over again. You'll notice that the highest that sine will ever reach is 1, and the lowest it'll ever reach is -1. Cosine is the exact same thing. So if you notice that these waves, if you like maybe squint a little bit, these almost look exactly the same. There's only one real difference. The difference is that in cosine, instead of starting at 0, 0, it starts at 1. And it goes all the way down to 0 at pi, and goes all the way back up to 1 at 2 pi. And again, just like sine, I take this little piece and repeat it over and over and over again, both in the future and in the past. They're repeating waves over and over again. The basic info you need to know, the period, again, if you think of this as a wall, like one repeating brick, this brick repeats from 0 to 2 pi. You don't have to worry about horizontal and vertical axis. But remember, the amplitude is 1. Amplitude meaning how high does this go. So it always goes as high as 1 and as high as -1. So this is for sine x and cosine x. And then don't worry about key point. I don't even know where they got that from. All right. So now how do you do the translations? Okay. So here's the basic equation, and depending on what values there are for A, B, C, and D, tells me how I'm going to change this graph. A is the amplitude. So remember, in a normal sine or cosine graph, the amplitude is 1. So whatever number this is will becomes the new amplitude. So if this becomes 5, that means the highest the graph will ever get is 5 and as low as -5. If A is 10, it goes as high as 10 and as low as -10. Sine, cosine. B represents the period. So remember, normally this wave repeats every 2 pi. But whatever number is here under B, I will take 2 pi and divide by that number, and that will be my new period. So if there's an invisible 1 in front of x, my period will be 2 pi. If this is 2, if b is 2, that means my new period will be pi. C and D are numbers that you should be well familiar with. C, because it's with the x, because it's inside the parentheses, it tells me to move left and right. And the D, because it's outside the parentheses, outside the x, tells me to move it up and down. So those two, C and D, should be very familiar. A and C are the new things that you haven't seen before. So let's practice, and the cool thing about these notes is that it breaks it down step by step for each piece instead of doing everything all at once. So number 1 says graph for cosine x. Okay. So the only difference between the base model of cosine x, okay, so remember we know how to graph cosine x. The only difference is that there's a 4 out in front. And what does that 4 out in front do? Looking at my equation, the number out in front represents amplitude, which means it changes how high and how low this graph goes. So remember, cosine starts at 1. Well, because the amplitude is 4, it's actually going to start at 4. And the lowest it'll ever get, instead of -1, will now be -4. Okay. My period stays the same. There's no number here. I'm not shifting it left and right, so my period still becomes 2 pi. So what I like to do is I like to draw like the period and the halfway point. And the cosine graph looks like this. And then you can repeat it on and on forever. And I know some of you are going to get confused and say, oh no, but you can do this. All right, example number 2, or the second part of example number 1. The difference between this one and the first example we did is instead of cosine, it's now sine. And the amplitude instead of 4 is now half. Okay, so you can take a guess, or I can't ask you guys, but what's going to change between this graph and the one that we just did? Okay, first thing, instead of going all the way up to 4, it's only going to go up to half. I know this isn't to scale, and you might want to make this smaller, but I don't think you'll be able to see this on the video if I did the actual half. And another difference is that this is sine, and sine, remember cosine actually starts at a number, remember it started at 1, but sine starts at 0, 0. The period doesn't change, there's no number in front of x, and there's no numbers out here, so it's going to be the exact same thing. Remember, I like to do 2 pi, I like to do, I like to do the period and the halfway point, so the period's 2 pi, the halfway point is pi. And to draw it, it looks like this. And that's the period, and then the last part, you're going to make it continue forever. Yay. Alright, so that's what happens if you change amplitude. What happens if we change the period? Alright, so this one says sine x over 2. And so you might be saying, I don't get it already, or what do I do now? Okay. Let's look back at our original equation. Remember, the number in front of x, I will divide, 2 pi will be divided by it, and it'll give me my new period. Okay. So in this one, it might be a little bit tricky, but this one, what is going to be b, or what's going to be the number in front of x in this problem? I don't know if you guys can see it or understand it, but the number in front of x is actually, and maybe if I rewrite it, you guys can see it. This is technically the same thing as sine of half x, right? Exact same thing as sine of half x, which means my new period will be 2 pi over half, or 2 pi divided by half is the same thing as 4 pi. Or if you don't know how to do that, you can do it in your calculator or figure out 2 divided by half, or how many halves are in 2, which is 4. So my new period is 4 pi. My amplitude has not changed. My amplitude is 1, and I don't have any numbers out here. So my new period is 4 pi, which means my halfway point is 2 pi. My amplitude is 1. And because it's sine, I start at 0, 0. So my graph looks like that. And it'll probably look prettier. I'm doing this on a mouse, so it's not as great. All right, how about this one? What's my period going to be for this one? The number out in front of x is pi. So my new period will be 2 pi over pi. Or my new period is going to be 2. Okay, so my new period is 2, which makes my halfway point what? Yeah, 1. My amplitude, what's my amplitude for this problem? Yeah, 1, negative 1. And because it's sine, I will start at 0, 0. So my graph will look like this. And I forgot to do it for the last problem that we did, but remember, you're going to let this wave go on forever. It's not a graph that stops. It's a continuing wave that goes on forever. And again, it's probably prettier on your papers. Okay, let's do one with some horizontal translations. Okay, so looking at this problem, I noticed that my amplitude is 1. My period is going to be 2 pi because I have no number in front. But now I have this plus pi over here. What does this plus pi mean? This plus pi means I'm going to move it. Remember, this plus means I'm going to move it to the left pi. So you don't need to write this down, but it means I'm going to take the original graph and move it to the left pi units. Okay. So my amplitude is negative 1 and 1. My period is 2 pi, so my halfway point is pi, and this becomes 2 pi. So remember, sine, I normally start at 0, 0. But since I'm moving to the left pi, I'm actually going to start here at negative pi. So remember, sine, I usually start at 0, 0, but because of this plus pi, I need to go to the left by pi units, and then I'll do my sine, my normal sine graph. So I'll go up to negative 1, to pi, down to negative 1, and then up back to 2 pi. Again, it should look prettier on yours. This next example, you'll notice is the exact same thing, except for 2 changes. One, it's cosine, and one, I have an amplitude of 2. Amplitude of 2, I'll change this to 2 and negative 2. And then I'm going to move this over back a pi. My period is still 2 pi. That hasn't changed, so this becomes 2 pi. My halfway point is pi. And I'm going to put a negative pi here because I'm going to have to move it back or move it to the left by pi. Remember, cosine doesn't start at 0. It starts at the amplitude. So I'm going to start actually up here. And I will go down and back up. And I noticed when I did this, I made a mistake on this problem. In this thing, maybe I'll do a red line. Whoops. Maybe I'll do a black line or a blue line instead. But you'll notice in this problem, remember I moved everything to left pi. So this actually should have stopped at pi. I know I probably confused you guys, but it normally ends at 2 pi, but since I moved everything to the left, it doesn't end at 2 pi anymore. It should end to the left one, if that makes sense. So forget this graph that I did for you guys. I made a mistake. What it should look like is like so. I'm going to go up to the amplitude, back down to 0, and up to pi. So that was my mistake. Sorry if I confused you guys. So for this example, I want you to practice some horizontal, some vertical translation, some amplitude, and some period. The worksheet I'm going to give you has it in both degrees and radians. So you need to be comfortable graphing sine and cosine, whether it's in degrees or radians. Okay. If you want to, I guess an example. Remember, in degrees, instead of this being 2 pi, this will be 360. And the halfway point of the pi will be 180. So the only difference between degrees and radians is this should be 360 and this should be 180. And we'll practice together if you guys are confused. Okay. You're going to turn this to a worksheet at the end of class. I'll give you guys the key on Monday so you guys aren't confused. I'll close, only have 10 seconds to show you just a quick picture of the baby. There he is. Very cute, very small. I hope you guys have a great weekend. and I'll see y'all on Monday. Take care.